Okay, let's again look at this reference. Let's look at another reference. Now, again, we are trying to understand the word meaning of process. And then next step will be I will try to come up with a connection between the word process, the definition, and what a typical industrial engineer does with that. Okay, so this is my basic plan. So this is another reference. Progress is the advance in the process of time. So you can also imagine that as time flows, that's also a process. It can be considered as a process. But we all know that everything that we have used in the previous definitions also have a time component. Okay, so we're not talking about a single directional thing, but there are a number of components like time, maybe resources used, so on and so forth. Something going on, a natural phenomenon marked by gradual changes that lead toward a particular result. So this is a little bit different, but I think it's more or less the same idea. Before going further, phones off. Okay? Okay. 3 years ago, I made somebody call the classroom. So if your phone was on, I would catch it from there. Not this lecture, of course. I didn't organize it yet. So I can do that. I'm really serious on this. Very, very serious. Anyway. Okay. Next. So why did we see all of these? Now, the reason of all of these is as follows. Now, industrial engineers are interested in processes. Actually, we make a living with the word process because everything that we do is related to either designing a process, improving a process, or observing a process. This is what we do for a living, actually. But what type of processes are we talking about? We're going to come to that. So I will take these two definitions that I liked most compared to the others. A systematic series of actions directed to some end. So here, I want to discuss this part first. So we're talking about processes that has a purpose. In other words, we want to have a purpose in the process. So we're not very much interested in the natural processes, like water is flowing. Well, we're not interested with water if water is flowing. But if we are going to have a dam barrage on that water so that we can obtain electrical energy by hydroelectric power, okay, then we will be interested in the river process, which includes the dam and the procedures that enable us to get the energy. Okay? But we're not interested in natural processes, which has, of course, some end in itself, but we are generally 99% of the time interested in human-made systems. Okay? So, for example, the previous example, we have a dam there, and it's built by humans. So there is a human touch on the natural resource. So we call it a human built process or human built system. Now, so we are going to have this sum end. And this sum end would be either to do something profitably or to do it for a certain use which you have to fulfill, so on and so forth. Okay? So this is actually the important part. There should be an end. Now, some authors, which we are not going to read, but there are some authors which call the systems that engineers deal with as purposeful systems. Purposeful. Okay? This is an important word. Which means that it serves a certain purpose. It's not arbitrary. Now, usually the purpose is goes hand in hand by the economics of it. In other words, whether it is profitable or less profitable and so on. But there is always a purpose. Okay? And so that's something that distinguishes the process that we use with some of those definitions that you are going to see in the other sources. Okay, now the second thing, we are talking about systematic series. So we're not talking about something that is arbitrarily done. It means that there is a certain logic when you are constructing those actions. Actually, it turns out that industrial engineers are going to break this large problem into smaller problems so that each of them can be dealt with separately in a certain way. And they are going to be connected systematically, hopefully, at the end. And there will be different actions that you take for each small part. And then at the end, you're going to come up with the larger issues that I gave examples, like how are we going to operate this hydroelectric dam, which is not a simple problem. You have millions of different aspects to that. But basically, by breaking the problem into smaller parts, by understanding the process of making that problem putting that problem into smaller parts, we are going to come up with an approach to hopefully deal with those problems. But those problems are seriously difficult problems. So hopefully in the university, what we're going to learn is, we're going to learn how to take that problem and how to analyze that problem, how to see this process of inter-systematic series of actions. And for some actions, maybe we will devise a small mathematical structure which is going to deal with that action in the best possible way. Okay, that is something that we are going to call decision. We're going to have decision there, but this is going to be what we will be devising hopefully at the end. So when you look at the definition of the process, a systematic series of actions, as IEs, what we're going to do is we're going to first observe the whole process, understand what the whole process is, and then systematically come up with a certain way of improving it or designing it if it is something new. Okay? And we're going to use our techniques here and there, but basically our understanding, engineering orientation is going to bring all of them together. Okay. A series of actions that produce or change or there is, I think, something wrong here. Something is missing. A series of actions that produce a change or development. That produce a development. Okay. So you might actually either develop it from scratch or you might change something which is current. Now let's give the example of registration. Now if you are doing this analysis for Bilkent's registration system, okay, you are going to improve it, of course, because there is a current one there. But if you are asked to do it for a new university, you are going to develop it yourself. Okay, so it's the same thing. One of them requires changing the current one. The other one requires designing a new one. But both of them have similar principles. Okay? So IEs usually would take part in both of those decisions. So things to remember here in my discussion. What's an action mentioned above? Each action is a certain sub-problem that we perceive from the process that we observe. Okay? So in order to take that action, we can either, in an ad hoc way, come up with a certain way of taking that action, or as industrial engineers, we can sit down, use our structures that we are going to learn in later years, and we're going to see some examples in this course, come up with the best way of doing that thing by itself. For example, let's say that the first action requires you to go from point A to point B. Okay? So point A is somewhere in Ankara. Point B is somewhere in Aydın. Okay? Anybody from Aydın? Okay. Okay, so I'm not from Aydın. I will always do that. Okay. But we're talking about two different streets. So from this point to Iden. Now, there are a number of alternative ways of going to Iden. Am I right? Like, if you are driving a car, you can use different routes. If you are taking a bus, you can take a direct bus, or you can take different buses. So you can see that I'm going to take that action. But there are different alternatives way of doing it. How am I going to go there in the best possible way? What's the definition of best? Okay, so we're going to deal with these type of issues. We're going to define the performance criteria that we are using so that we can find out the best if we can. And then we're going to have some methods that we are going to utilize to come up with the best possible action within the whole problem that we are talking about. Okay, so these are the things that we're going to see in this course and in other courses. So each action is actually a decision to make, at least one decision to make. But you first have to understand that when you look at the problem, you have to make sure that you can differentiate different actions. Because they are usually related, but you have to make sure that you pose them in a certain way so that they can be disintegrated and you can make decisions. Now, if you think about all of them at the same time, it turns out that the problems that you encounter are huge and they are of massive structure. And if you don't approach in this way, you won't be able to solve. Now, engineering problems, 99% of the time, it requires you to divide first and then conquer each of them one by one. This is the word by, I think, a British foreign secretary. The way that they looked at the world in the 19th and 20th century of the British Empire was, you have to divide the countries into smaller parts so that you can conquer them easily. Now, this is the engineering approach, actually. You have a huge problem that you see you don't know how to approach, but by analyzing the problem, you divide the problem into smaller parts. You try to come with a solution to each of them one by one. And then at the end, you're going to connect them and present your solution. This is what we do, actually. This is what all the engineers do. These are the things that, and the rest of the world, they don't do anything. Okay. No, of course, they do something. Okay. Any questions on this? So this is actually what we will be using. Now, the things that we deal with can be in a manufacturing system or in a service system. It doesn't matter. There is a conceptual mistake that people who doesn't know industrial engineering usually make. They say that, oh, industrial engineers, they usually work in manufacturing sector. No, we don't work in a specific sector. We only work in establishments where there are problems which are complex enough. Regardless whether it's a manufacturing sector or a manufacturing problem. Most of the problems in a manufacturing sector are not related to the actual doing of manufacturing. Okay? So this is actually very important to understand. We don't have a sector that we work. Actually, none of the engineers, maybe except petroleum engineers and mining engineers, have a sector, have a well-defined sector. The remaining do not have a sector. It can be either a manufacturing system or a service system, it doesn't matter. The important part is that you need to have a complex enough problem where you can create alternatives. There are certain problems which are very simple. You don't have alternatives. You don't need an IE. Any smart person can solve that problem. You need IEs if you have a complex problem, because then we have our special approach, special methods to approach the problem and solve those actions in the best possible way. Otherwise, it will be very simple. So it can be manufacturing or service system. The production that we're talking about is not necessarily a physical production. Of course, it can be a physical product. It means that I am interested in manufacturing of these items. Or it can be a service. What do I mean by a service? Manufacturing these pens are not sufficient to sell them. What do you have to do? What is the next step? Let's say that I manufactured this in the next room, and I want to sell them. How can I do that? I have to distribute. So it means that I have to carry them somewhere in order to be able to sell. And carry there to whom? Well, to maybe Migros, okay, or to Carrefour, places that I can sell these items. So that distribution is also actually a product. How are you going to manage that? Okay, there might be very simple solutions, but they may not be economical. So that's what we call a service. If you are doing this, carrying it over, it's not a manufacturing job, but it's carrying it over. But it's definitely related to the manufacturing. You have to manufacture first, obtain the product, and then move it. Without having the product, you cannot move anything. Okay? You can only move money, actually. Without producing, the only thing that you can move around is money. Okay? That includes money laundering. Do you know the term money laundering? Okay. Illegal money flowing from one country to the other. Okay, because you don't need to produce. But other than that, everything that you see around requires somebody to manufacture it and somebody to move it to that specific point. Or it can be a method. I can come up with a design with a method of doing certain things. For example, I may create a know-how where I am specialized in registration systems for universities. There are some people like that. So I have a know-how, but all the university environments are different, of course. They are not the same, so you cannot put the same system. But at least if I am experienced in that, I can do that design. So these are the things that we call a product when we are giving examples. It's not necessarily a physical product. It can be a service, product, or a design. And improvement is the most important part. We're going to have a number of examples related to that. But this is actually the way that we are going to look at in this course. First, we will understand how to observe certain phenomena so that we can create series of actions that are presented in that specific example. Okay? And we will do that by some very simple examples starting next time. Okay. Next time, it means next week. Okay, any questions? Okay. Now, what are we going to do tomorrow? Well, this is actually, no. Okay, this is my course schedule for the next 2 weeks. If you can solve this, you have 5% from me. Now, it's very simple, actually. Now, the top level is today. All sections, we are here in between. I am 5 minutes late. Okay? Now, the second one is next week. Next week, we're going to meet here, same time, and 2 hours. We're going to use 2 hours. Now, section 01. Now, for tomorrow, I'm going to break section 1, all the sections actually this week, into 2 groups. So the first group is going to come in the first hour of the 2 hours. The second group is going to come in the second part of the 2 hours. And how am I doing this? For the first section, if your last name is in between A and H, including H, you're going to come to the first hour. If your last name, section 1, is in between I and Z, you are going to come in the next hour. If your last name is in between, but excluding I, H, and I, okay? I don't know whether it is possible, but let's say that it is possible, then you can come to any section you want, okay? If your last name is in between, okay? So next week, on the other hand, we're gonna come all together to the same section, and these are the hours. Now, every week, every 2 weeks, I'm going to send something like this to you with an email. Then we're going to laugh when some of you in the classroom are going to make mistakes. Okay? We're going to laugh because there will always be some people making mistakes. Any problems in understanding this? It's not finished yet. Any problems? Okay. Tomorrow we're going to have, in tomorrow's sections and Friday sections, we're going to have a quiz. In that quiz, I'm going to ask you the process that you went through while selecting industrial engineering as your choice in the university entrance exam. Now, I will send the exact wording of the question that I am going to ask you through email. And I will ask this question in the quiz tomorrow morning, starting tomorrow morning, in 8 of these sessions. And let us see how you are going to respond to that. So that will be the first quiz for 2.5%. This is the easiest 2.5% that you are going to get. And this is what I will be doing tomorrow and on Friday. Any questions? Now, those of you who are repeat students, please stay here. The others can leave.